Welcome to solverfy.
Okay, we have a drop of water, or we're asked about a drop of water and told that that contains about 0.049 milliliters. And we're also told that water has a density. This is the symbol rho. That's typically the variable used for density. Has a density, we can assume, of 1.00 grams per centimeter cubed. Okay, and the question we're asked is how many molecules in one drop of water. Okay, so we know milliliters, but what we'd like to know is molecules. Now, they did tell us density, which will convert milliliters into, or volume into grams. And if we have grams, we can get moles. And if we have moles, we can get molecules using Avogadro's number. So it looks like our path is clear, but there's a couple things we have to figure out. We are told the volume in milliliters, but they've given us the density in grams per cubic centimeter. Well, it just so happens that 1 centimeter cubed is equal to 1 milliliter in terms of volume, so that's perfect. So we can say that the density is also 1.00 grams per milliliter. All right, so then we could work out the mass of our drop of water. We can say 0.049 milliliters times, and then we say 1.00 grams over milliliters. At this point, milliliters cancel and we have grams. And then I was thinking we could go to moles, and from moles we can go to molecules. So how do we get to moles? Well, we use molecular weight. Recall that molecular weight relates mass to moles. And the molecular mass of water is 18.01528 grams per mole. Well, we want grams in our denominator to cancel with this grams, and we want moles in our numerator to give us the unit of moles. So what we really want is 1 mole contains 18.01528 grams of water. The grams would cancel, leaving us with moles, and now all we have left to do is convert moles to molecules. Well, if you recall, the definition of a mole is that 1 mole is comprised of 6.022 times 10 to the 23rd molecules. And yes, that is Avogadro's number. That's what Avogadro's number tells us. It relates molecules to moles. And so at this point, we will have, with consideration of our units, canceled milliliters, canceled grams, canceled moles, and we're left with molecules. So let's then write out our final answer after putting it into our calculator. So I've got 0.049 times 1.00 divided by 18.01528 times 6.022, and then I use the EE button to do 10 to the 23rd. I say EE 23 equals, and the number that I get is 1.6379 times, that would be not very many, right? Times 10 to the 21 molecules, right? And so all told, if we consider rounding to the 2 sig figs we were supplied for our volume of water, we would get 1.6 times 10 to the 21 molecules of water.